All right, here we go. Continuing our notes on functions, we're going to pick up with even and odd functions. These are notes pages 12 and 13 in your notes packet. Again, today we're talking about even and odd functions. Let's take a look at a few examples. Here I've got this U-shaped graph, and I've got like this S-shaped graph. This one on the left is an even function. And what defines an even function is that for all x in the domain of a function, f of negative x is equal to f of x. Likewise, for an odd function, this one on the right, we're saying that for all x in the domain of f, f of negative x is equal to negative f of x in the domain of f. So if we're thinking back at our previous section when we talked about transformations, an even function is where we're saying the function is the same even when you reflect over the y-axis. Okay, so we're saying that the function is the same on both sides of the y-axis. In particular, a function is an even function if it's symmetric about the y-axis. For an odd function, we're saying that if we reflect over the y-axis, the function is the same as though we reflect over the x-axis. Okay, so if we have our function here, we're saying that if we reflect over the x and the y-axis, then we have the same function. Okay, in particular, our function is symmetric with respect to the origin. So if we were to take all of these values and rotate them 180 degrees around the plane, we're going to have the same function on the other side. Okay, so let's go ahead and formally define these. We'll start off with even functions. An even function, we'll say if a function f satisfies f of x equals f of negative x, so that reflection over the y-axis, for all x in the domain of f, then we say that f is an even function. If a function f satisfies f of x equals f of negative x for all x in the domain of f, then f is an even function. In other words, our function is an even function if it's symmetric about the y-axis. So a few examples of even functions, well, the parent function for a quadratic is an even function. It's symmetric about the y-axis. Another one, we could say the absolute value function, y equals the absolute value of x. So now we're going to determine whether or not f and g are even functions algebraically. So let's take a look at f. So we have f of x equals, and I'm just rewriting it, x to the fourth plus 2x. Now, in order to determine algebraically whether a function is an even function or not, we can plug in negative x. So we're going to find f of negative x. So plugging that in, we have, and use parentheses, negative x to the fourth plus 2 times negative x. Okay, we're going to simplify this. So we have negative x to the fourth. Well, that's equivalent to just positive x to the fourth, right? We have an even power, so that deals with that negative. So we have x to the fourth. And then we have 2 times negative x, that's minus 2x. Now, is that the same? Is f of negative x the same as f of x? It's not. We have different signs here. So here we can say f of x is not an even function. Let's go ahead and plot this into our calculator to see what the graph looks like. So go ahead and take out your TI Nspire. We'll open up a new document and we'll open up a new graph. And we want to plug in the original function, x to the fourth plus 2x. And we'll see what that graph looks like. So looking at the graph here, we can see that the function is not symmetric about the y-axis. In fact, on the left-hand side of the y-axis, in the negative x, we have negative y's. But on the right-hand side, we don't. On the positive x side, we don't have any negative y's. It's all positive. So this is not symmetric about the y-axis, so therefore f is not an even function. So let's go ahead and explain how that graph supports your conclusion. We'll say that f of x is not symmetric about the y-axis. Okay, let's take a look at g. So g of x is x squared minus the absolute value of x. Okay, so let's go ahead and find out what g of negative x is. So plugging in negative x, we have negative x squared minus the absolute value of negative x. Okay, so negative x squared, again, we have an even power, so we can say that that is equivalent to just positive x squared minus, well, the absolute value of negative x is equivalent to the absolute value of positive x, right? That's the absolute value function. So we could say this is the absolute value of x. So is g of negative x the same as g of x? It sure is. We have exactly the same thing. So algebraically, we have shown that g of x is an even function. Let's take a look at the graph. So let's take out our calculator and we'll plug in the function. So I'm going to hit tab to get back up to my functions. We'll take out that first one. And we'll put in our function x squared minus, and then to get the absolute value function, we're going to click on this button just to the left of the book. And all the way to the right, we see the absolute value. So we enter that. And we're going to hit x. Taking a look at the graph, if we were to draw a line on the y-axis, this is symmetric on both sides. Okay, this is the same on both sides. We see that it goes up on both sides and it goes below the x-axis on both sides. This is symmetrical. So graphically, we can say that g of x is symmetric about the y-axis. Let's try a few more examples. Here I've given you the graph and a table of values, and I want you to fill in the rest such that these are even functions. So I've given to you that this is already an even function. We just have to draw in the rest of the graph. So using what we know about even functions, they're symmetrical about the y-axis, we can just draw in the other half on the left-hand side of the y-axis. So I see that it comes up here, it comes down and hits negative 1, 0. We've got this little curve right here between negative 1 and negative 3. And it comes up and hits the point negative 2, 1. And then it curves back upward all the way up here. So this is symmetrical, and so this is an even function. Taking a look at a table of values, now remember when we're filling this in, we want h of x to equal h of negative x. That's the definition of an even function. So if we have h of x, say h of 3 is negative 5, well then h of negative 3 should also be negative 5. They're equal. Likewise, if h of negative 1 is negative 3, h of negative 1 or positive 1 is negative 3. Likewise, you might also have recognized that x equals 0 is our y-axis, so it should be the same on either side. All right, let's talk about odd functions. Go ahead and flip the page. So we already talked a little bit about what odd functions are. We're saying that if you rotate the graph 180 degrees around the plane, then you're going to have the same thing. So, in particular, let's give this a definition. We'll say that if a function f satisfies, now the definition here is f of negative x equals negative f of x. So we're saying a reflection over the x-axis is equal to a reflection over the y-axis. Other way around. Y-axis is equal to x-axis. For all x in the domain of f, then f is an odd function. So if a function f satisfies f of negative x equals negative f of x for all x in the domain of f, then f is an odd function. A few examples of odd functions, we could say any parent function for an odd degree polynomial, so x cubed or a cubic function, that is an odd function. Even our linear function, y equals x, that's an odd function. We could also say that the cube root function or any odd root, is an odd function. So y equals cube root of x. Let's find out whether or not f and g are odd functions algebraically. So I'm just going to write out f again. So f of x equals x cubed plus 2x. And I need to find f of negative x and negative f of x. So let's go ahead and find each of those. So f of negative x, we plug in negative x, we have negative x cubed plus 2 times negative x. Well, negative x cubed, this is an odd power, so that negative stays. This is the same as negative x cubed. And then 2 times negative x, so that would be minus 2x. Let's find negative f of x. So negative f of x, we're going to take f of x and just make it negative. So negative, and then just plug in f of x. So x cubed plus 2x. And then we distribute our negative. So we have negative x cubed minus 2x. Well, are these two equal? They sure are. They're identical. So we can say algebraically that f of x is an odd function. Let's take a look at the graph. So going back to the graph, we can take out that even function. We have x cubed plus, I hit times, plus 2x. There we go. And you can see this function is an odd function. If you were to take everything in quadrant 1, rotate it 180 degrees, it would land exactly in quadrant 3, the same way that it is in quadrant 1. So this is symmetric about the origin. So we're going to say f of x is symmetric about the origin. Let's try for g of x. So g of x is our reciprocal function, 1 over x. So then we need to find g of negative x. Okay, so we'll plug in negative x. So we have 1 over negative x. That should be on the inside. Negative x. There we go. Okay, we can bring that negative on the outside. So we have negative 1 over x. Let's do the same for negative g of x. So we have negative, and then whatever g of x is, so 1 over x. And again, we have negative 1 over x. These are the same, so g is also an odd function. So g of x is an odd function. Let's take a look at the graph. So back to our graph. We're going to take, the reciprocal function. So 1 over x. And we get this here. Again, everything in quadrant 1 rotated 180 degrees around the plane is what we have in quadrant 3. So this is an odd function graphically. So g of x is symmetric about the origin. Okay, let's try these last two. So here I've got just quadrant 1, and we're told that it's an odd function. So remember what we know about odd functions. It must be the same rotated 180 degrees around the plane. So if I'm going to take this and rotate it, it's going to be upside down and in quadrant 3. So we're going to kind of have this shape here where it comes loops low and then shoots back down. Okay, so let's do that. I want to include the origin. We've got the point 2, 4, so let's include the point -2, -4. Again, negative x and negative x and negative f of x. Okay, so we have the point 4, 0, so let's include -4, 0. You could also include this point down here. So our graph, again, loops low, comes back up, hits the x-axis, and then shoots back down. So you can see if we rotated the graph 180 degrees, we'd have this finished graph here. All right, let's fill in the table of values. Again, by definition for the odd function, we can say h of negative x is equal to negative h of x. So if I want to find h of negative 3, so fill in this blank, I know that h of 3 is negative 5. So h of negative 3, or negative x, must be negative 5, or positive 5. Likewise, if I want to find h of 1, well, we know that h of negative 1 is negative 3. So then h of negative 1, or h of 1, must be negative 3, or negative h of x. So that would be positive 3. Okay. Again, our y-axis is right here. And we are rotating 180 degrees. So all of these values are going to be flipped. All right. So this is our notes on even and odd functions. We're going to get a whole lot of practice on this. So we'll see you tomorrow in class. Have a great day.